Welcome to this video about test about a proportion. Today we're going to run a full 4-step process on a significance test about proportions. So by the end you should be able to perform the entire significance test about a population proportion. So in our scenario today, many students claim that they can taste the different colors of Skittles. Today we will conduct an experiment and perform a significance test to see if students really can taste the rainbow. So I collected some data. Out of 150 total Skittles eaten, 97 of them were correctly identified. Okay, so let's go with our state. So we have our parameter. We want to identify our parameter, and we want to know the true proportion of correctly guessed Skittle flavors. All right, so that's what we're trying to find out. Our statistic comes from our sample, remember. So we've got 97 out of 150 were correct for a sample statistic of 0.647. Okay, so almost 65% were guessed correctly. So now our hypothesis. If people were truly guessing, the hypothesis, they should guess 20% correctly, because there are 5 different flavors of Skittles, and so if we're just randomly guessing, we should get about a 20% correct guess. So what this will mean is our null hypothesis is a population proportion of 0.20. That's if they're just guessing. Okay, now our statistic is more than this 0.20. So our alternative is we think something else is going on. So we think the population proportion is greater than 0.20. Okay, and we're going to use an alpha level of 0.05. That's still that 5% that we've been comparing with all along. All right, so now be sure to take good notes here, because this is what all of the information I'm expecting to show up when we answer with our 4-step process. So our procedure, remember we talked about we had 1 sample and 2 sample Z intervals for proportion. That's what we talked about last unit. That's because we were making confidence intervals. This time we're performing a significance test, and we're using the information from 1 sample. So we have a 1 sample Z test. Test is for significance for a proportion. Okay, so now we have 3 procedures: 1 sample Z interval, 2 sample Z interval, 1 sample Z test. Okay, now we do need to check our conditions just like always. So for our random, it is a random sample of Skittles that we had. Okay, for your 10%, we had 150 Skittles. Well, that is definitely less than 1/10 of all Skittles. And then the last one, we got to be sure to check for proportions. We always check our large counts. So we had a sample size of 150. And we're going to use, from our hypothesis up here, 0.2, which gives me 30, which is greater than or equal to 10. And then we had 150 times 0.8, which was equal to 120, which is greater than or equal to 10. So our sampling distribution is approximately normal. Now remember, we have random here because that is so we can generalize to the population. Okay, and then we had our 10% rule because we were sampling without replacement, but as long as our sample isn't too big, it's all right. Sampling without replacement is okay. It's still considered independent, so we can use the standard deviation formula that we've been using. And then the large counts, of course, is so our sampling distribution is approximately normal. All right, so for the general formula, remember that's when we write it in just the words. So I'm going to use the official words, the standardized test statistic. That's your z-score. Okay, and you need to find the z-score, you take your statistic minus your parameter, and then you divide it by your standard deviation. So in this case, that looks like z equals p hat minus p divided by p times 1 minus p divided by n. Now we're not using p hat there like we did last time, because right here, because we have a claim and we claim that the population, we say that that's the population number, okay? So we're not saying it's p hat. So let's just make a little note for these guys right here. Use the claim, not p hat. Okay. All right. And we do that because we assume the null is to be true. So we assume the null is true. Okay. And that's why we're going to use the population numbers right here. All right, so let's plug in our work. So we have z equals, our statistic was 0.647 minus our parameter of 0.20 divided by our standard deviation of 0.2 times 0.8 divided by 150. Okay, we want to be sure we draw a picture of what we're talking about. So we want to know what's the likelihood of being this extreme or further, sorry. So we have our normal curve, and we know it's normal because we did our large counts. The mean is at 0.2 because that's what the claim is. That's the population. So n, we're saying it's normal with a mean at 0.2. When I found the standard deviation, I just calculated just this portion of it, and I got 0.0327. So that's our standard deviation. Okay. So 0.2 is here, 0.647 is somewhere over here. So it's above the mean, so we want to know what's the likelihood of being that extreme or further. So we're wanting to know that area. Okay. So let's get a z-score so we can go look up the area. So when I calculated this out, I got a z-score of 13.68. Now wait a minute, a z-score of 13.68. That is over 13.5 standard deviations above the mean. So what's the probability of being that many standard deviations above the mean or greater? Well, it's essentially 0. There's really not a whole lot out there. So our p-value is approximately 0. Okay, it's not equal to 0, it's approximately 0. It can happen. There is a possibility. However, it's essentially 0. All right, so let's do a conclusion here. We've done our state, plan, do, and then you always need to have a conclusion. So when we do this, we did this in our other problems, we're going to put two sections together. First, you always want to say you assume the null to be true. So assuming the null is true, and here I'm just going to put to remind the reader that p equals 0.2. Now we want to talk about what does that, if this is true, there is a 0% probability of getting a p-hat, a 0% probability of getting a p-hat of 0.647 or greater purely by chance. So what we're saying is we really think something else is going on. Okay, so let's follow this up and say, well, what does that mean then in relation to our null and alternative hypothesis? So if the null is true, there's almost no chance of getting the result that we got. Okay, so because our p-value, so we're going to say because 0 is less than, and then we're going to compare it to that alpha that we had up here. That's that 5% that we've been doing all the time. 0 is less than 0.05. That makes it really unusual. That means we don't think the null is true, so we reject the null. Okay, so if we reject the null, what does that mean for our alternative? Okay, so our alternative was the probability was greater than 0.2. Okay, we have convincing evidence that this class can taste the rainbow. They weren't just guessing, because if they were guessing, it would have been close. It would have been 0.2 or closer to it. But we were well beyond it, and significantly well beyond it. So we say we think they can actually taste the Skittle flavors. Okay, so here this is our conclusion, and in our conclusion you're going to be sure to include interpret the p-value, okay, that's that first part. Assuming the null is true, how likely is our result? Okay, and then we have to make some sort of decision. Okay, and the decision occurs right here. That's our decision. Because we're less than the 5%, that means we don't think the claim or the null hypothesis is true, so we reject the null. Okay, so that's your decision. Which is right there. Okay, and then you have your conclusion. About the alternative. So you start off, we assume the null to be true, and if it is, this is the probability of what we got happening. Then we're going to compare what we got compared to the alpha and decide, does that mean we're okay with the claim, or are we rejecting the claim? Do we fail to reject or reject? If you reject, that means you have convincing evidence for the alternative. If you fail to reject, that means you do not have convincing evidence for the alternative. Okay, so it's one or the other. You're okay with the null or you're not okay with the null, but we got to address all of these things in here. So let's flip this over and kind of summarize this down for you. All right, for our 4-step process, in the state section, I need you to define your parameter. You need to name what your statistic is. You want to include your hypotheses. And whatever your alpha equals. And the problem usually tells you. If the problem does not tell you, then you're going to use 0.05, which is that 5%. Okay, then our plan. In the plan, you're going to name your procedure. So in this case, we did one sample. We're going to do a z-score. So we're going to say z, and this is a significance test. So you write the word test. And we're talking about 4 proportions. And you also want to check your conditions. Right. Then we have do. You want to include your specific formula. So you remember which formulas are which. You want to show your work. You want to say what your test statistic is, your z-score, and what your p-value is. All of that and a drawing. All of that needs to be in there. Okay, and then your conclude. I'm going to run out of room here. So your conclude, you need to interpret the p-value. Okay. And interpreting the p-value is that assume the null is true statement, where you make that comparison, how likely is this going to happen if this is true. Then you need to make a decision. So your decision is going to be reject the null or fail to reject. I'm going to say FTR, fail to reject the null. And then you have to, the last part is you got to make a conclusion. Okay, so does that mean, do we have evidence for or no evidence for the alternative? Evidence or no evidence for the alternative? Okay. So that's a lot, but that's going to get you, if you're consistent in practicing it this way, when you hit a test situation, you're used to writing everything down in a particular way, and it really helps you under stress of an exam. All right, so that is our 4-step process for a significance test for proportion. And let's remind you, when we actually do the do part, to find your test statistic, which is your z-score, take your p-hat minus your parameter, and you're going to divide by p times 1 minus p. Now those numbers come from the claim, remember, okay? And divide by your sample size. So use your null hypothesis there. You should draw the picture, but one thing I want to tell you about is we have talked about P being, for your alternative, P being greater than or P being less than. Right now I want to mention, what if P is just not equal to? Okay, because you're going to run into that situation in this check your understanding. So if P is not equal to, that means it's really a two-sided test. We don't know. They're not meaning one direction or the other. They're meaning both directions. So when you draw your picture, you're going to have your mean down here in the middle, and you're going to end up saying, I want to know the information for both of those areas out in the wings. Okay? So if it's a two-sided test, pull will, the P does not equal whatever your claim is. So P does not equal the null value. And when you find your p-value, it's really, you're going to look up this p-value right here. So whatever your z-score is, you're going to look up the negative version of it and tell me what this number is. Well, this area is going to be equal to this area because it's going to be symmetrical. So you're going to take your p-value and multiply it by 2. Okay, and how do you know if it's going to be this two-sided test? So the way you can determine is when you're reading the question, you're going to see, I'm going to show you where the hint is right here. What is the probability that the kids differ? The word differs is really important here. That's the one that it's not giving you a direction of greater than or less than. We want to know about if it differs from. So you're looking for the word differs or is different or something along those lines that's not indicating a direction, but it's meaning actually both sides. Okay, so once you get your p-value here, so you run it the same way. You find your z-score, you find your p-value, multiply the p-value times 2, because these areas they're talking about in both directions. Being different from is going both ways. So they're going to be equal to each other because the normal curve is symmetrical. All right, so hopefully that made some sense. Let me know if you have any questions, and I'll see you in class.
Yeah.